Sima, the next topic which we are studying is electric potential. So, see what is the definition of potential. Amount of work done to bring a unit positive charge from infinity to any particular point up to here, okay, in the field of a charge. That amount of work which you have done, that is called as potential. Clear now? So how can I define potential at this point P? Potential is nothing but work done to bring unit test charge. This is called as potential. So potential ante meeru work done ani gurtupettukondi. What is meant by potential? Work done. Work done to do what? Work done to bring this charge, unit test charge, from infinite separation. So this is a main charge, bigger charge, mother charge. Okay? So from this main charge, this test charge is at a very large distance. So long distance that there is no either attraction or repulsion between these two charges. These charges madhyalo attraction ledu, repulsion ledu. So it means it is at a very large distance. No? So from this distance, if I want to bring a charge through any path, whatever may be the path I bring, that doesn't matter. Okay, ma? Because work done is a scalar quantity. No? Work done does not depend upon direction. Meer ela techina okate. Clear nama? So if I bring the charge through any path up to this point, okay, then definitely I should do some work. No? Why I have to do some work? Work enduku cheyali? Because test charge means positive charge, no ma? Main charge is also positive, no? So if I start bringing this one closer, force of repulsion will be present, no? Between one positive and another positive charge. What kind of force is there? Repulsive forces are present. So to oppose these repulsive forces, I have to do some work, or I have to apply some force. Force multiplied by displacement is nothing but work. Are you able to understand me? So therefore, that amount of work which I am doing per which charge, per the charge which I have moved. Okay, ma? This is the charge which I have moved, no? Then move chesina charge ide kada, Q not. So work done per unit charge is nothing but potential at this point P. Is it clear? Are you able to understand? So this definition you should not forget. You will deal with many equations of potential, but basic definition you should not forget. Are you able to understand? ఇంటికాడ నుంచి బయలుదేరి ఊరంతా తిరుగుతాం మనం. ఊరంతా తిరిగి ఇంట్లో మర్చిపోయినాం అనుకోండి, కష్టం అనమాట. ఇది కూడా అంతే. ఓకే, బేసిక్ డెఫినేషన్ యూ షుడ్ బి వెరీ క్లియర్. ఓకే మా? నౌ సీ, ఫర్ ఎగ్జాంపుల్, ఇఫ్ ఐ గివ్ యూ ఎ క్వశ్చన్, ట్రై టు ఆన్సర్ దిస్ క్వశ్చన్ మా. సి, సో దిస్ ఈజ్ అ మెయిన్ ఛార్జ్ ప్లస్ Q. ఓకే, and I am taking 2 points, point A and point B. So potential at point A is VA, potential at point B is VB. Now can you say where potential will be greater? This is main charge, ma. These are 2 points A and B. Are you able to understand? So potential at point A is VA. Now this is present at a distance of R1. Okay, ma. Let us write this one somewhere here. So this is point B, ma. Here potential is VB, and the distance of this point is R2, and R2 is greater than R1. Clear? Now can you say where potential will be greater? VA is greater than VB, VB is greater than VBA, or both are equal? VA is greater than VB. How can you say? Distance takku unte. Is there any relation of? Okay. Yes, we can say like that. Okay, ma. Point is that to bring this charge more closer, I have to do more work, no? Because if I travel greater distance, if distance increases, work done increases, no ma? Clear, no? So I am bringing this charge very closer from infinity, and this one I am bringing to a bit farther distance. So therefore here work done will be lesser, here work done will be more. ఛార్జ్కి ఎంత దగ్గరగా మీరు తీసుకొని వస్తే అంత ఎక్కువ వర్క్ చేస్తారు కదా మీరు, బికాస్ యాజ్ డిస్టెన్స్ ఇంక్రీజెస్ వర్క్ డన్ ఆల్సో ఇంక్రీజెస్. అండ్ వన్ మోర్ మెథడ్ ఇన్ విచ్ షీ సెడ్ ఈస్, ఇఫ్ ఐ కమ్ వెరీ క్లోజర్, దెన్ ఫోర్స్ ఆఫ్ రిపల్షన్ ఇంక్రీజెస్, నో మా. సో టు అపోజ్ దట్ ఫోర్స్ ఐ హ్యావ్ టు అప్లై మోర్ ఫోర్స్. సో బై దట్ ఆల్సో వీ కెన్ ఎక్స్ప్లెయిన్ work done will be greater. So definitely I can say that potential at point A is greater than potential at point B. Okay, so this is the definition of potential. Is it clear? Sima, here definitely potential at point A and potential at point B, they are not same, no? So this difference of potential VA minus VB is called as potential difference also, man. Okay, potential difference. So what is meant by potential difference? Okay, potential difference is nothing but difference of potentials between 2 points. Okay, so to bring that charge from infinity to this point, here I have to do different amount of work, and here I have to do different amount of work. So that difference of potential is nothing but potential difference. Ante potential difference ante. Is it clear? Sima, for example, in a circuit we will be connecting batteries, no? For example, this is a resistor and this is a battery. Okay, so if I supply battery, then I see that the current flowing in the circuit. For example, bulb, fan, refrigerator, all these are resistors. Okay, and resistors work only when current is passed through them. And how current passes? By supplying some potential difference. So what battery does? Battery ఏం చేస్తుంది చెప్పండి? Battery just provides a potential difference in the circuit. Okay, so on the battery you should have seen two terminals, positive terminal and negative terminal. It means that this positive terminal, it is at a higher potential, and this one is at a lower potential. So here potential will be positive and here potential will be negative. So electric current or charge always flows from positive potential to negative potential because it provides a potential difference. Are you able to understand? So that potential difference is defined like this. So here the amount of work done will be different, here the amount of work done will be different. So this potential is different and this potential is different. So difference of potentials is nothing but potential difference. Okay, so or write down this statement. So what can you write here? What is meant by potential difference? Difference of potentials, difference of potentials between 2 points. This is called as potential difference. Okay, Sima. So next we are studying a very important relation, that is relation between electric field and potential. Okay, what is meant by electric field already we have studied, no? Force experienced per unit test charge. So in a field, test charge is experiencing how much force? That force divided by charge is nothing but field. And work done per unit charge is called potential. So we can derive a relation between field and potential. So derivation part I am not doing. This is the relation we should remember. E is equals to minus dV divided by dr. It means a field at a region is how much? The difference of potential divided by distance between the points. Is it clear? Okay, ma? So dV means what, ma? Change in potential between 2 points. So at B, different potential, at A, there will be different potential. So difference of potential is given by dV, very small difference, and dr is the distance between them, very small distance. So per a small distance, what is the change in potential? That ratio is nothing but field. This is how you can define relation between field and potential. Are you able to understand, ma? For a small distance, potential changes by how much value? That is called as field. For the same distance, if potential changes by greater value, it means in that region field is also greater. Are you able to understand? How we define a potential field, that I am explaining you. Okay, ma? No need of definition, just for your understanding. This equation you are supposed to remember, ma. E is equals to dV divided by dr, or you can call it as negative potential gradient also. What is another name for electric field, ma? Negative potential gradient. Negative potential gradient means what? Negative means negative. Potential gradient means what? Change in potential per distance. For a small amount of distance, potential changes by how much value? That is called as negative potential gradient, or you can just call it as electric field also. Okay. Now this equation I can write like this also, no, ma? So I can write minus dV is equal to E into dr. So if I integrate on both sides, dV is very small change, delta V is change. So minus integration of E into dr. So delta V can be written as VB minus VA. Delta V means a change in potential, no? So potential at point B minus potential at point D. So this is equal to integration of E into dr. Dr is nothing but distance, no? So from where to where I am integrating? From point A to point B. So my limits of integration will be A2. Okay. So these are the two equations which you should remember for deriving relation between electric field and potential. Clear number? One is equals to minus dV by dr, or you can write VB minus VA is equals to negative integration of A to B. You should not write B to A, A to B. A to B, E into dr. These are the equations. Clear? Right now. Okay, ma? See here. So this is a very important concept now which we are studying. So many times questions were given on this topic. So see ma. So electrostatic field is a conservative field. What is meant by conservative forces we have studied in work power energy, no ma? What is meant by conservative force? Conservative force means work done in a closed path will be zero. That is called as conservative force. Are you able to understand, ma? So for example, in a conservative field, if I start from point A, travel throughout the region and reach to the same point, then work done will be how much? Zero. That is called as a conservative field. Gravitational field is an example of a conservative field. That's all, no? So if I throw this pen upwards, then I have to do some work. Okay, ma? And when pen again reaches to the same position, then again I am receiving the same amount of work. It means total work done will become zero. That kind of field is called as conservative field. Gravitational field is a conservative field. Spring force is a conservative field. Similarly, electrostatic field is also a conservative field. Total work done in a closed path will be how much, ma? Zero. So write down that definition. So total work done in a closed path is how much? It is equal to zero. Okay. So let us see how we can prove that one, Sima. So I am present here, or you can consider there is a test charge present at point A. Where I am taking test charge, I am taking test charge at point A. So from point A, I am moving to B, then B to C, C to D, and again from D to A. It means I have completed one circular path, no? Okay. So what is the point I have started? I have reached to the same position. So it means I have completed a circular path. Now see. So work done to travel from A to B is how much? What is the amount of work done to travel from A to B? Okay. How much? See ma, here potential in vector form can be written like this also. VB minus VA is equals to negative integration of E dash dot dr dash in vector form. Or you can write E dr cos theta also, because A dash dot B dash is AB cos theta only, no? So E dash dot dr dash is E dr cos theta. Now what is meant by theta here? Theta is the angle between electric field and the distance which you are moving. E means direction of electric field. Dr means the distance in which you are moving. Clear? I am starting from A, I am reaching up to B. Okay. So dr is in which direction? Dr is in perpendicular direction to the direction of electric field. Ante kada? Electric field is horizontal, but I am moving vertically. So what is the angle between E and dr? 90 degrees. So cos 90? 0. So what is the work done to travel from A to B? 0. Are you able to understand why we got 0, ma? So if work done is 0, potential difference also will be 0 only, because potential is nothing but work done. Already I said, you know, potential ni meer ela gurtu pettukovali? Work done per unit charge. So if work done is 0, potential difference between 2 points also will be 0. So definitely I can say that potential B minus potential at A, it will be equal to 0. There is no difference of potential between these two. Or also I can say potential at point B is exactly equal to potential at point E. Are you able to understand? So here one more point which I can say is, if you travel perpendicular to the field, then you need not do any work. Or if you want to carry a charge from A to B, you need not do any work. Why? Potential difference is not there, no? Are you able to understand, ma? Between A and B, there is no difference of potential. So therefore, you need not do any work to take a charge from point A to point B. Are you able to understand, ma? Okay. Similarly, now can you say what is the amount of work done to travel from B to C? Or I will calculate potential difference between VB minus VA. How much ma it is? So minus integration of E into dr into cos theta. Okay. Now can you say theta value is how much? 180. Electric field is in this direction. No? Electric field is towards the right side. But I am traveling in which direction? I am traveling in opposite direction. So angle is 180. No? So cos 180. So minus integration of E dr cos 180. Cos 180 value is minus 1. So therefore what is the total potential difference? So minus of minus will become plus. Plus no ma? So integration of E into dr. That's all no? So this is the potential difference between which points ma? B to C. So VB minus, I am traveling from B to C, no, I have to write VC minus VB. This is how I have to write. Because I am starting from B, no ma, I am reaching up to C. Potential difference means a final potential minus initial potential. VC minus VB. So that is minus integration of E into dr. Is it clear? Okay. Now similarly I will move from C to D. C to D ma. Okay. So in moving from C to D, how I have to write? VD minus VC. How much? How much? 0. Okay ma? So there is no potential difference between C and D. C ki D ki madhyalo potential difference ledu endukala. Because C and D distance is perpendicular to the field. No? Whenever you travel perpendicular to the field, you need not do any work. Because potential difference does not exist. Is it clear? Are you able to understand ma? Similarly, potential difference between the D and C will be 0 ma, because they are this distance is perpendicular to electric field. Clear no? Similarly, now I travel from D to A. D to A. So how can I write this one? VA minus VD. So minus integration of E dr cos 0. That's all. No? 0 only, no? Why 0? Because the distance is in this direction, displacement is in this direction, field is also in the same direction. So angle between them is 0. Okay. Cos 0? 1. So therefore, VA minus VB is how much ma? It is minus integration of E into dr. Sorry. What did I write? A to B na? Oh, sorry. D to A no? So I have to write VA minus VD. VA minus VD. Clear no ma? So therefore, this is the total amount of potential differences between these 2 points. Okay. Now if you add all of them, okay ma? So work done is how much? Potential is nothing but work done per unit charge no ma? So work done is nothing but potential multiplied by Q naught. It means just you have to add all the potentials. Clear? So initial potential 0. If work done is 0, potential difference also will be 0. Or you can write it as delta V also, change in potential. Okay? And VC minus VB is how much? Plus E into dr. Okay ma? Then again 0. Now plus minus E into dr. Okay ma? Multiplied by Q naught. So what is my total work done? Total work done is 0. Are you able to understand? So this is just to prove that if you travel in a closed path in an electric field, you need not do any work. Work jaragadu. Are you able to understand ma? Because I am starting from A and I am reaching up to A only. No? So between A and A, is there any potential difference? No. If potential difference is not there, delta V, if it is 0, work done also will be 0. That's it. Is it clear? So therefore, completed ma? So therefore, to travel perpendicularly in a field, you need not do any work. So by doing this experiment, what we have understood ma? For example, this is a field, electric field. Okay ma? To start from point A and to reach up to here, what is the work I have to do? I need not do any work. To travel perpendicular in a field, I need not do any work. Okay ma? So if work done is 0, work done can be written as a change in potential multiplied by charge which you are carrying, no? So if work done is 0, it means a change in potential is also 0. Okay? It also means that potential at point B is nothing but potential at point B. Both points. Okay. So electric potential due to point charge. So this is plus Q, and here at this point P at a distance of R, I want to find out potential. What is meant by potential? Yesterday we have studied, no? Can you say? Potential is nothing but work done per unit test charge or unit charge. Clear, no? It means some charge Q naught it was present at infinity. It was present at infinity. And from here, if I want to bring this charge up to here, then definitely I have to do some work, no? So that work done per the charge which you have carried. If you divide both of them, then you will get the potential. So therefore, potential because of point charge. There is a definition which I am not doing. So this can be written as 1 by 4 pi epsilon naught Q divided by R. This is the equation to calculate potential because of a single point charge. Clear, no? Or just you can write it is Q divided by 4 pi epsilon naught into R. So this is the equation of potential. Okay, ma? See how to remember them, see, ma. Force between two charges 1 by 4 pi epsilon naught Q1 Q2 divided by R square. This is the equation of force, no? Force between two charges. Electric field because of any charge, it is 1 by 4 pi epsilon naught Q divided by R square. And potential because of point charge, 1 by 4 pi epsilon naught Q divided by R. Okay? So what are the differences, can you say, ma? Force, field and potential. So here instead of Q1, Q2, if I write single Q, then it becomes the equation of field. Clear, no? And here instead of R square, just if I write R, then it becomes the equation of potential. Like this you can remember. Okay? So next we write electric potential. Electric potential is a scalar quantity. Okay, ma? Electric potential is a scalar quantity. How can you say it is a scalar quantity, ma? How can we say it is a scalar quantity? ఎందుకుండదు? Oh. Okay, ma? Potential is what? Potential is nothing but work done per unit charge, no? Work done is a scalar quantity. Work done scalar quantity only, no? So work done per unit charge also is a scalar quantity, so it does not have any direction. But remember, force is a vector quantity. Electric field is also a vector quantity. Basics you should not forget. What is meant by electric field? Electric field is nothing but force experienced per unit test charge. Force is a vector quantity. Field is also vector quantity. Potential is work done per unit charge. Work done is scalar. Potential is also a scalar. Are you able to understand? Okay. Now, see, for example, I want to calculate electric potential because of group of charges. Due to group of charges. Okay. So there are some charges, and because of these charges, I want to calculate potential at a point. Okay. See, so consider here there is a charge of plus Q1, here there is a charge of minus Q2, and here there is a charge of plus Q3. Okay, ma? And here somewhere at a point P, I want to calculate a potential because of all these charges. Okay? And from Q1, this point is at a distance of R1. From Q2, this point is at a distance of R2. From Q3, it is at a distance of R3. Now can you say, how can I calculate a potential at point P? How to find out resultant? Chappandi. Clear, ma? Anybody? Same type of calculation we have done for electric field also, no? Now here we are doing for potential. How to find out the total resultant of all the potentials at point P? How can I calculate? Direction. ఇక్కడ ఏం రాసుకున్నావు? మరి డైరెక్షన్ ఎక్కడి నుంచి వస్తుంది? Potential is a scalar quantity. See, one thing which I have observed is, మీరు నోట్స్ సరిగా చదవటం లేదు. అర్థమవుతుంది కదా? నోట్స్ సరిగా చదవకుండానే ఏదో అట్లా చూసేసుకొని ప్రాబ్లమ్స్ చేయడానికి వెళ్తూ ఉన్నారు మీరు. అట్లా మీరు ఇంకో 10 సంవత్సరాలు చేసినా ఏమీ రాదు. అర్థమవుతుంది కదా? ప్రాబ్లమ్స్ చేసేది ఎందుకంటే మనకు సబ్జెక్ట్ క్లియర్గా అర్థమైందా లేదా అని టెస్ట్ చేసుకోవడానికి. మీరు ప్రాబ్లమ్స్ నుంచి సబ్జెక్ట్ నేర్చుకోవాలంటే అది కష్టం. అది పాయింట్ పైన మీకు క్లారిటీ ఉండాలి. ఫస్ట్ లైన్ దగ్గర నుంచి లాస్ట్ లైన్ వరకు నోట్స్లో ఉన్నది పర్ఫెక్ట్గా మీకు వచ్చి ఉండాలి. దాన్ని మళ్ళీ ఒక 2-3 సార్లు రాయాలి. ఏం జరుగుతుంది అనేది 2-3-4 సార్లు రాస్తే అప్పుడు మీకు అది మనసులో కూర్చుంటుంది అనమాట. దెన్ యూ గో ఫర్ ప్రాబ్లమ్స్. ఇది చేసే పద్ధతి. మీరేదో అట్లా నోట్స్ చూసేసుకొని ప్రాబ్లమ్స్ చూసిపోతూ ఉన్నారు మీరు. దట్ ఈస్ వెరీ బిగ్గెస్ట్ బ్లండర్ యు ఆర్ డూయింగ్. ఓకే, దాంతో రిజల్ట్ రాదు, గుర్తుపెట్టుకోండి. ఓకే, సీమా వాట్ వీ స్టడీడ్ దట్ పొటెన్షియల్ ఈజ్ ఎ స్కేలార్ క్వాంటిటీ. నో, potential is a scalar quantity. So just you add all the magnitudes of potentials which are existing at this point. Okay, so at point P, how many charges will give potential? 3 charges will give potential. Potential is work done. So therefore it depends on the type of charge also. No, are you able to understand? See, for example, this is plus Q and here there is a test charge. Are you able to understand? So if I want to bring this charge in this direction, then I have to apply force in which direction? I have to apply, for example, this is a charge Q0. I have to apply force in which direction? I have to apply force in this direction. This is the direction of external force. Why? Because repulsion will be in opposite direction. No, force due to repulsion, it will be in opposite direction. What is the reason? They are like charges. No, force of repulsion will be there. To oppose this force of repulsion, I have to apply force in opposite direction. So here work done by external force is how much? It is positive. Clear? No? Why work done by external force is positive? Because I am applying force in this direction and I am also moving in the same direction. Are you able to understand? But let us consider this is minus Q, negative charge, but I am placing a test charge. Test charge is always positive. No? So if I want to bring this charge up to here, then I have to apply force in which direction? So force of attraction will be in this direction. No? Negative charge will be attracting the positive charge. Clear? No? So therefore to oppose this attraction, I have to apply force in opposite direction. Are you able to understand the differences between these two? So here if work done by external force is negative, here work done by external force is, here if it is positive, here it is negative. So therefore potential at a point depends on type of charge, whether it is positive charge or negative charge. Are you able to understand? So therefore how can I write? Because of positive charge, it is plus Q1 divided by 4 pi epsilon naught into R1. This is the potential because of first charge at a point P. Clear? No? Because of point charge, what kind of work I will do? Positive work. Clear? No? And because of next charge, second charge is minus Q2. So minus Q2 divided by 4 pi epsilon naught into R2. R2 is the distance. No? And the third charge is again positive. So plus Q3 divided by 4 pi epsilon naught into R3. So this is the total potential existing at point P because of all the 3 charges. This is how you have to write the potential. Are you able to understand? In the case of electric field, what we do? We draw the directions. Okay, already we studied. No, positive charge will experience force in the direction of electric field. Negative charge will experience force in opposite direction to the direction of electric field. So in calculating net electric field, we draw the directions and we try to take the resultant, because field is a vector quantity, but potential is a scalar quantity. You are supposed to take, whether it is plus Q, you take plus Q. Whether it is negative charge, take minus. That's it. You will get the total potential acting at a point. That's it. Okay? Make a note. Okay. So next concept is potential, electric potential because of dipole. What is meant by dipole? Already we have studied. No? Dipole means two equal and opposite charges separated by a small distance is called as dipole. And at any point at point P, which is making an angle of theta with the center of the dipole, I want to calculate electric potential. Then this is the equation. Vp is equals to P cos theta divided by 4 pi epsilon naught into R square. This is the equation. Derivation is there? No need of derivation, just remember this one. Now, here by using this relation, we will study some cases now. Okay? Case number 1 is point P is on the axial line. Okay, ma? Point P is on the axial line. It means this point P, it is present somewhere here at axial line. Okay, ma? Consider this is point P. Now, can you say how can I calculate a potential at point P, ma? Anybody? When point P is here, theta will be how much? 0 degrees. No, in the 188 was right? 0. So therefore, when point P is on the axial line, how much angle this point is making with respect to dipole? It will make an angle of 0 degrees. So therefore, Vp is equals to P into cos 0 divided by 4 pi epsilon naught into r square. Okay, ma? See, ma, for point charge, Vp is inversely proportional to r only. But for dipole, it is inversely proportional to r square. So don't be confused here. Okay? Already we studied, no, ma? For point charge, what is the potential? 1 by 4 pi epsilon naught, q by r only. But for dipole, it is r square. P cos theta by 4 pi epsilon naught into r square. Where what is P? P means what? Dipole moment. Dipole moment. Clear, no? Cos 0 value 1. So therefore it is P divided by 4 pi epsilon naught into r square. So this is the equation to calculate a potential at axial line of the dipole. Clear, no? Next we study case number 2. So case number 2 is point P on the equatorial line. Okay, ma? When point P is on the equatorial line, theta value? 90 degrees, that's all. No? So theta will be 90 degrees. So therefore, potential at point P is how much, ma? P cos 90 divided by 4 pi epsilon naught. 4 pi epsilon naught into r square. Clear? No? Cos 90 value? 0. So total potential will be 0. Okay? Now can you say why potential will be 0, ma? So this is minus q and this is plus q. Okay, ma? So here at a point P on the equatorial line, which is making an angle of theta, we studied that potential will be how much? Potential because of point P at point P will be 0. Are you able to understand what is the reason? Aithe? Work done, no? Enduk 0 Anybody, can you say? What is meant by potential basically? Work done per unit test charge, no? This is called as potential. Clear, no? See, somewhere at infinity consider there is a test charge q naught. Somewhere at infinity. So I want to bring this test charge from here to this point through any path. Okay? Then what is the force of attraction given by this minus q? Same force of repulsion will be given by plus q, no? That's all, no? What is the force given by minus q? Same opposite force will be given by plus q. So these two forces, they get cancelled with each other. And net force, when it is acting 0, then definitely at this point work done also will become 0. If work done becomes 0, potential also will become 0. Understood, no? Basic definitions marchipokudu. Clear, no? For example, if you get a doubt of what is the potential at this point, always you can understand the potential by going to the basics once again. అర్థమవుతుంది కదా? మళ్ళీ బేసిక్స్ దగ్గరికి పోతే మీకు విషయం అర్థమవుతుంది. క్లియర్? రైట్ డౌన్. ఓకేమా? సీమా. So potential difference between 2 points in an electric field is 6 volts. Ma? So consider this is an electric field. Okay, ma? Uniform electric field E dash. So consider this is point A and this is point B. Okay, ma? So potential difference between these 2 points is 6 volts. So can I say VA minus VB is 6 or VB minus VA is 6? Which one is 6 here? Huh? VB minus VA is 6. How can you say? Oh. See, ma, here, if this is the direction of electric field, it means positive charges are present here, no? Direction of field చూడాలి first. If this is the direction of field. Okay, ma? It means positive charges are present here, and it means that negative charges may be present here also. May be present, may not be present. Okay, ma? Negative charges may be present, may not be present. Are you able to understand? So therefore, which one will have higher potential? The point which is closer to the charge, it will have higher potential, no? So point A is at a higher potential, point B is at a lower potential, because it is closer to positive charges, no? Okay? It means to bring a point charge from infinity to this point, I have to do more work when compared to work done to bring the same charge to point B. Are you able to understand? So therefore I can say VA is greater than VB. Potential at point A is greater than potential at point B. So therefore VB minus VA is not plus 6, it is minus 6. VA minus VB is plus 6. Are you able to understand? So therefore I want to bring a charge. Which charge? This much amount of charge. So this much amount of charge, 300 microcoulombs, it present at point B. So this charge I want to bring from point B to point A. Lower potential to higher potential. That's what he said, no? సో ప్రతి ఒక్క లైన్లో ఉన్న ప్రతి ఒక్క టర్మ్ని మీరు చూడాలి. అర్థమవుతుంది కదా? ఆపరేషన్ చేస్తే ఏమేమి ఉన్నాయో అన్నీ చూడాలి, పారామీటర్స్ అన్నీ కూడా. బీపీ ఎంత ఉంది, దీనికి షుగర్ ఎంత ఉంది, తర్వాత కిడ్నీ ఎట్టుంది, మిగతా పార్ట్స్ అన్నిటిపైన ఐడియా ఉంటేనే వాడు డాక్టర్ అవుతాడు. కోసి కుట్లేయడం ఎవడేం చేస్తాడు, నేను కూడా చేస్తాను. అది కాదు కదా డాక్టర్ అంటే. సో యూ షుడ్ బి వెరీ క్లియర్ అబౌట్ ఎవ్రీ స్టేట్మెంట్ విచ్ ఈస్ గివెన్. ఆర్ ఏబుల్ టు అండర్స్టాండ్? సో ఐఎమ్ మూవింగ్ ఫ్రమ్ lower potential to higher potential. If I am moving from lower potential to higher potential, work done by external force, is it positive or negative? ఇప్పుడే చెప్పింది. If I am moving from lower potential to higher potential, work done by external forces, is it positive or negative? Positive, no, because if I want to move this charge, here positive charges are present, no? They will be attracting, they will be repelling this charge. When it repel చేస్తూ ఉంటాయి, but I will push it in forward direction. And displacement is also in the same direction. So work done is positive. Are you able to understand? ఇక్కడ వరకు రాయండి. Okay, ma? So therefore in this condition, work done will be positive. And what is meant by potential or change in potential or difference in potential is nothing but work done per unit charge, no? Work done per unit charge. So therefore I will write VA minus VB is equals to W divided by Q. So therefore what he is asking? Work done only, no? So W is equals to VA minus VB multiplied by charge. That's all, no? So therefore what is the potential difference between both of them? 6. And what is the charge which we are carrying? 300 into 10 power minus 6. Okay, ma? So therefore work done is equals to 18 into 10 power minus 4 joules. So work done is equals to 1.8 into 10 power minus 3 joules. So this is the amount of work which I have to do. Clear? Okay, ma? Katama? 90 is correct. So see, ma, work done is 300 joules, no? And what is the charge which we are carrying? Charge which we are carrying is 3 coulombs of charge. So from which place to which place? Minus 10 to some potential is V. Okay, ma? So I will write VB minus VA is equals to work done per unit charge. Clear, no, ma? So VB means higher potential if work done is positive. Understood, no, ma? So VB will be greater than VA. In which condition? If work done is positive. Are you able to understand? It means if I am moving from lower potential to higher potential, my work done will be positive. This already we have discussed many times. So therefore higher potential is V. Lower potential is minus 10. Okay, ma? So this is equals to work done. Work done is how much? 300 divided by what is the charge which you are moving? 3 coulombs of charge. And coulombs is SI system, no, ma? You need not convert this one into anything. So V plus 10 is equal to 100. So therefore V is equals to 90 volts. That is our answer. Okay. See, let us see what is the question he is giving. So there are 2 point charges. This is one point charge Q1 and this is another point charge Q2. So it is 16 into 10 power minus 10 and this is 12 into 10 power minus 10 coulombs. Okay. So initially they are find work done in bringing 2 charges 4 centimeters closer. 2 charges 4 centimeter closer. Sorry. Okay. Sima. So what is the initial separation between them? Initial separation between them is 10 centimeter. Clear, no? So initial separation between them is 10 centimeter. Okay. Now what I am doing, I am bringing these 2 charges 4 centimeter closer. It means now what is the final distance between them? 6 centimeter. 10 minus 4, 6 hai. So final distance is 6 centimeter. Then I have to calculate how much work will be done. So how I do this problem is, Sima. So because of this charge or because of this charge, any charge you can take. Because of this charge, initially I want to calculate a potential at a distance of 10 centimeter. Okay. See how we can do this calculation. So calculate potential because of 116 into 10 power minus 10 at 10 centimeter. Means here I want to calculate potential. How can I calculate potential? Potential at, let it be point P. So potential at point P is equals to Q by 4 pi epsilon naught into R. This is the equation of potential. No? So therefore I will write what is the main charge. Charge is 16 into 10 power minus 10 divided by 4 pi epsilon naught into R. R value is 10 centimeter. So 10 into 10 power minus 2 meter. This is the potential. Clear, no? Okay. Now let us draw the new configuration. New configuration is, this is Q1, 16 into 10 power minus 10. And this charge which is present at 10 centimeter, now I will bring this one to a distance of 6 centimeters only. So this charge I am displacing. This charge I am displacing. This one I am keeping constant. Are you able to understand? Now here what is the charge present? It is 12 into 10 power minus 10 coulombs. Clear, no? And left this point is point X. Now what I will do, I will calculate the potential at the point X because of which charge? Because of again the same charge, 16 into 10 power minus 10. Clear, no? Previously I calculated potential at 10. Now I am calculating potential at 6 centimeters of distance. So therefore how can I calculate? Charge is same only, 16 into 10 power minus 10 divided by 4 pi epsilon naught multiplied by how much distance? 6 into 10 power minus 2. That's all, Rama. So therefore what is the potential difference between the 2 points I can calculate? No? Potential at point P, potential at point X, they are different. No? So which one is at a higher potential? Point X is at a higher potential or point P is at a higher potential? Point X is at a higher potential. Why? Because it is closer, no? Ma? It is closer to the main charge which I am taking. No? So definitely at a point X potential will be greater. So therefore potential difference, how can I calculate? Vx minus Vp. That's all, no? So do the calculation. So what are the terms which are constant? So 16 into 10 power minus 10 divided by 4 pi epsilon naught multiplied by 10 power minus 10 is also common, no? Multiplied by 10 power minus 2 divided by 1 by 6 minus 1 by 10. Clear, number? So this is the potential difference between 2 points. Now once I calculate potential difference, can't I calculate work done? Now work done find out cheyochu kada. How can I calculate work done? Work done is nothing but Vx minus Vp multiplied by charge which you have moved. Which charge you have moved? We have moved this charge, no? So just write the charge there. Is it clear? That's it. So therefore work done is equals to so 1 by 4 pi epsilon naught can be written as 9 into 10 power 9 number. 1 by 4 pi epsilon naught value 9 into 10 power 9 multiplied by 116 into 10 power minus 10 divided by 10 power minus 2 multiplied by 1 by 6 minus 1 by 10 multiplied by the charge which we have moved. Which charge we have moved? We have moved 12 into 10 power minus 10. So multiplied by 12 into 10 power minus 10. So just do this calculation, I will get the amount of work which you have to do to bring the charges together. Is it clear? So the answer which I should get is 11.52 into 10 power minus 8. That much amount of work I have to do. Okay? Understood how we have done? ఒక్కొక్క ప్రాబ్లం చేసినప్పుడు మనకు ఇది డెఫినేషన్కి ఎలా రిలేట్ అవుతుందని చూసుకోవాలి. గుడ్డి చదువులు చదవకూడదు. బ్లైండ్ ఎడ్యుకేషన్. Sima. So, a test charge Q0, it is moved without acceleration from P to Q in a uniform electric field in the given path. What is the path given here? We are starting from P, directly we are not moving up to Q. Okay? So, first of all, we are moving up to R, then from R I am moving to Q. That is what is happening. So, therefore, in this condition, we are supposed to calculate what is the difference in potential between P and Q. Potential difference between P and Q, we are supposed to find out. Are you able to understand? Okay, ma? See, already we have studied one point, you know. What we have studied? We have studied that electric field is a conservative field. Okay, ma? Electric field is what kind of field, ma? Conservative field. Conservative field means what? It does not depend upon path taken by the body. That is called conservative field, no? I will write once again here. So therefore, work done does not depend upon path taken. This is one definition of conservative force. Or you can also say work done in a closed path is zero. That also I can say, no? That also I will write down. So also one more definition of conservative fields is work done in a closed path is how much? Work done in a closed path is zero. That also I can write. Are you able to understand? Now it means that if I travel from P to R and R to Q, same amount of work will be done if I travel from P to Q also. Point is same, no? Are you able to understand, ma? ఊరంతా తిరిగి ఇక్కడ పోయినా ఒకటే, డైరెక్ట్ నుంచి ఇక్కడి నుంచి పోయినా ఒకటే, సేమ్ వర్క్ యూ విల్ డూ. Are you able to understand? So you need not do this total calculation. Just simply how can you write? I can write path PQ I will take. Path PQ. Okay, my first method of solving. Path point P, point Q. Just if I travel from P to Q. Now am I traveling from lower potential to higher potential or higher potential to lower potential, ma? I am traveling from lower potential to higher potential because I am traveling in opposite direction to the direction of electric field. So here positive charges will be present. Already I said, you know. Then only electric lines of force will be traveling away from the positive charge. Clear, no? So therefore, how can I write? I can write VQ minus VP is equals to negative integration of E dash dot DL dash. And from where I am moving? From P to Q. This is how I can write the relation, no? Already we studied, no? So VQ minus VP, final point minus initial potential is equals to negative integration of E dash dot DL dash. And I am moving from P to Q. Clear? Now, what is meant by E dash dot DL dash, ma? E dash dot DL dash means what? Dot product, no? What is the full form? What is the scalar form of dot product? EDL cos theta. That's all. And what is meant by theta? Theta is the angle between what? Electric field and the path in which you are traveling. So field is in this direction. dr is the displacement in which you are moving, no, ma? I am moving in which direction? I am moving from P to Q, opposite direction. So what is the theta value? 180 degrees, cos 180. So therefore, how can I write? I can write VQ minus VP is equals to negative integration of E into DL into cos 180. Cos 180? Minus 1. Minus 1 and minus will get cancelled, no? So cos 180 and minus I can cancel. Clear, no? So therefore, VQ minus VP, field is a constant, no? Field is constant field. So E is a constant. Integration of dl. E is a constant, I am taking out of integration. dl is very small distance. Integration of dl means total distance. Total distance between what and what? P and Q. And distance between P and Q is given as d. So substitute it. So therefore VQ minus VP is equals to E into D. That's all. This is my answer. Okay, ma? So this is one method of doing the calculation. Okay? Make a note. See, ma. See here, first of all I will travel from P to R, ma. P to R. Now in traveling from P to R, what is the angle made by electric field and path, ma? Is it 45? Electric field is in this direction, no? This is 90. And this is the path in which you are traveling. 90 plus 45 antara? Amara atlo vachindannamata. Student. Okay, ma? So, first of all, I am traveling from P to R, ma. So, integration of EDL cos 135. Clear, no? So, therefore, cos 135 can be written as minus 1 by root. We know how to convert angles, no? Minus 1 by root. So, minus get cancelled. So, this is the answer which I got. So, E is a constant, no? I will take out of integration. So, dl by 1 by root 2. So, integration of dl. dl is very small distance, no? Integration of dl means total length which you have travelled. Total length is nothing but PR, no? Total length is nothing but PR. So, E into PR into 1 by root 2. Instead of 1 by root 2, can I write again cos 45? 1 by root 2 value cos 45 only, no? Now see. So, if I split this PR into two components, adjacent side will be PR cos 45 only, no? Are able to understand, ma? So, instead of PR cos 45, can I write a D? Instead of PR cos 45, I can write D, no? Splitting vector into two components. Clear, no? So therefore, VR minus VP is E into D. It means instead of PR cos 45, I am writing a D. Clear, no? Okay. Now see. So now I reached up to point R, no? Ma? I reached up to point R. Now I have to travel up to point Q. Okay. But point R and point P, they are perpendicular to electric field, no? R and Q. This line is perpendicular to electric field. So in last concept, what we said. So if there are any points perpendicular to electric field, potential difference between them is 0. There is no potential difference. It means what is the potential at point R, same potential will be at point Q also. So instead of VR, I can write VQ, no? Clear, no? So instead of VR, I will write VQ. So therefore VQ minus VP is equals to E into D. That was the same answer which we got previously, no? That's it. Yeah, okay. No. Student, see this problem? So, 4 point charges are present at the sides of an square. So, plus 1, minus 1, plus 1, minus 1. This is the arrangement of charges. Okay. Then, at the middle, there is a point O, and at one end of the center of BC, we have another point E. So, I want to carry an electron from point O to point E. Okay, ma? Then what is the amount of work done? That is what he is asking us to find out. Clear, no? Work done depends on what? Potential difference multiplied by charge only, no? So, final potential is VE, initial potential is V0, multiplied by the charge which I am carrying is an electron. This is the amount of work done. That's all, no? It means, first of all, I have to calculate a potential at point E. Then you calculate a potential at point O. Then you subtract both of them, multiply by charge of an electron, then you will get the answer. Ante kada? But daniki endendo cheptaru endi meeru? Are able to understand, ma? Work done is nothing but potential difference between 2 points multiplied by the charge which you are carrying, and the charge which you are carrying is an electron. Clear? Now see. So first of all, I will calculate potential at point O. Point O. So at point O, how many charges are giving the potential? 4 charges, 1, 2, 3, 4. 4 charges will give potential, no? And this point O is equidistant from all the charges, no? This point O is at a distance of, if I consider this distance to be x. So every distance is x only, no? Okay. So therefore, what is potential at point O? It is 1 by 4 pi epsilon naught x if I take common. Then I have to add all the charges, no? One charge is minus 1 microcoulomb, another charge is plus 1 microcoulomb, another charge is minus 1 microcoulomb, another charge is plus 1 microcoulomb. Okay, Rama? Potential due to point charge, you know the formula, no? Q by 4 pi epsilon naught into R. 1 by 4 pi epsilon naught is common, no, for all of them. So just I am adding all the charges. Is it clear? So minus 1 plus 1, minus 1 plus 1, if I get cancelled, then potential at point O is how much? 0. It means at point O there is no potential. Is it clear? Now I will calculate the potential at point E. Okay, ma? Now can you say at point T who will give the potential? Huh? Here who will give the potential? B and C. ఈ రెండు ఏమైపోయినాయి భోజనానికి రెస్ట్ తీసుకొని పోయినాయా? So here also all the 4 charges will give the potential. Clear, no? Now see. So if this distance is, let it be y, then this distance also is y only, no? Clear, no? This charge also will give potential. This charge also will give potential. This distance, if it is y, this distance also y only. But this will give positive potential. Charge at A will give positive potential. Charge at D will give negative potential. So potential due to these two charges will get cancelled, no? Similarly, point B is plus 1. Here we have minus 1. And distance is same, no? So potential because of B and C also will get cancelled. Are you able to understand, ma? So therefore, what is the total potential at point E? 0. Potential due to these two will get cancelled. Potential due to these two also will get cancelled. So total potential at E is also 0. Are you able to understand? So write down, how can I write? Potential at point E is equals to potential due to this charge. So 1 by 4 pi epsilon naught minus 1 microcoulomb divided by y. And potential at point D is, this is plus 1 number, plus 1 by 4 pi epsilon naught minus 1 microcoulomb divided by y. Clear? And if I call this distance as 0.1, this distance as 0.1. So potential due to B will be how much? Again 1 by 4 pi epsilon naught plus 1 microcoulomb divided by 0.1 plus 1 by 4 pi epsilon naught minus 1 microcoulomb divided by 0.1. Okay. So if I do this total calculation, again at potential at E will be 0. Okay. Therefore, what is the equation for work done? Work done is nothing but VE minus V0 or V0 multiplied by charge. So therefore 0 into electron is 0. That is how we can explain work done is 0. Are you able to understand? ఏందో ఈ నుంచి లైన్ ఆ పక్కకు పోతుంది, ఈ పక్కకు వస్తే. డైపోల్ గురించి మాట్లాడుతూ ఉన్నావా? డైపోల్ గురించి ఇక్కడ తీసుకోవాలంటే కష్టం. ఎందుకు? చాలా డైపోల్స్ ఉన్నాయి ఇక్కడ. ఇదొక డైపోల్ అవుతుంది, ఇదొక డైపోల్ అవుతుంది, ఇదొక డైపోల్, ఇదొక డైపోల్. క్యాన్సిల్ అవుతాయని మీరు ప్రూవ్ చేసే లోపల 3 గంటలు అయిపోతాయి. Sim. So equipotential surface. What is meant by equipotential surface? In the name itself we can say, no, potential at every point is equal. Then such a surface is called as an equipotential surface. Clear? So potential due to point charge, what is the formula? Potential due to point charge is equals to Q divided by 4 pi epsilon naught into R. This is the formula, no? So therefore potential depends on what? It depends on distance, R1. So therefore if I take some points which are present at the same distance from the main charge, then at every point we will have same potential, no? So point P, point Q, point R and point S, all of them they are at the same distance. So therefore definitely I can say potential at point P is equals to potential at point Q is equals to potential at point R is equal to potential at point S. So all these points they are at the same potential. Or I can say that the sphere which surrounds these points, that is called as an equipotential surface. So around a 3-dimensional space, a sphere can be formed, no? Sphere. So on every point on the sphere, we will have same potential. Okay. So therefore, what we say? So the sphere equidistant from center. Okay, ma? Its surface behaves like what? from charge. Its surface behaves like an equipotential surface. Okay, ma? Equipotential surface. Are you able to understand? So therefore, see ma, one point which we should understand is work done to move a charge, on an equipotential surface, is how much? It is 0. Okay, ma? So on an equipotential surface, if you want to move a charge, you need not do any work. What is the reason? ఆడ వరకు బాగానే ఉంది సార్, రీజన్స్ అడగాకండి, చెప్పండి. వర్క్ డన్ టు మూవ్ ఆన్ ఈక్విపొటెన్షియల్ సర్ఫేస్ ఇస్ 0. వాట్ ఈస్ ద రీజన్? ఈక్విపొటెన్షియల్ అంటే మీనింగ్ ఎంత అసలు? పొటెన్షియల్ డిఫరెన్స్ ఇస్ 0. ఇఫ్ పొటెన్షియల్ డిఫరెన్స్ ఈజ్ how work will be there, work also will be 0. Because what is the equation of work done? For example, Sima, if I want to move a charge from P to Q, then work done, how I will write? VQ minus VP multiplied by charge. This is how I write. This is the equation of work done. So both the points are at same potential. So therefore, if you move like this, whatever path you move, it doesn't matter. But if you are moving between two equipotential points, then work done will be definitely 0. So this is one point which we should remember very carefully. Understood, number? One more point is that electric field or electric lines of force are always perpendicular to equipotential surface. Understood, Nama? So to an equipotential surface, what will be the direction of electric lines of force? They will be always perpendicular. It means that this is the equipotential surface, Nama. So therefore, if you draw electric lines, these electric lines will be exactly perpendicular to the perpendicular to this equipotential surface. Always it will make an angle of 90 degrees. Okay. For example, this is the direction of electric field or electric line of force. Then here angle will be how much? 90 degrees. Are you able to understand? Similarly, sometimes he will give question like this. For example, these are the electric lines of force. Okay, ma? Can you draw equipotential surface for this one? These are the electric lines of force, ma? Are you able to understand? Then for these 3 lines, can you draw equipotential surface? Very simple. You draw a surface such that everywhere it is perpendicular to these lines. Okay, no? Then automatically this surface will become a equipotential surface. Because what is the point here we have written? Electric lines of force are always perpendicular to equipotential surface. So therefore, equipotential surface should make always how much angle? 90 degrees with electric lines of force or electric field. Understood, no? Make a note of it. Sima. So, see the arrangement of equipotential surfaces. Theoretical bits will be asked on this concept. Okay, so listen. Consider this is a charge. So near the charge, potential will be greater. No? When we take any point very close to the charge, their potential will be greater. And if I move away from the charge, potential continuously decreases. Clear? So here, this is an equipotential surface. This total sphere which I am drawing, this surface is an equipotential surface. And how much potential is existing at every point? 100 volts. So it means that here also 100 volts, here also 100 volts, here also 100, everywhere it is 100. Okay? And if I want a difference of 10 volts of potential, then I have to draw 90 volts, no? 90 volts. But when you compare this R1 and this R2, R2 will be greater than R1. It means 90 volts potential surface, equipotential surface, it is present at a greater distance. Okay, ma? Difference is 10, but distance is greater. Then what is the next 10 volts difference? 80 volts. 80 volts is located at still a very far distance. Okay, ma? So this is R3. R2 and R1. R3 is greater than R2 is greater than R1. Can you explain why it is happening like this? So this total is an 80 volts equipotential surface. So everywhere you will find how much potential? 80 volts. So this total is one equipotential surface. This is an equipotential surface. This is an equipotential surface. So potential difference is same, 10 volts, 10 volts, 10 volts. But distances are not same. That is what we understand. What can be the reason? What can be the reason for this one? Okay, I will do one thing. I will give you a hint for you. So E is equals to minus dV divided by dr. Try to explain according to this one. E, but I am talking about V. Here difference in potential I am taking, no? dV. See, if you take dV is equals to minus E into dr, if I take this value. What is dV? Difference in potential, no? Difference in potential everywhere is same. From 100 to 90, 10. 90 to 80 also, 10 only. So dV is a constant. This is a constant. Okay, ma? But here, as I move away from the charge, E value continuously decreases, no, ma? Okay, what is E? Force experienced per unit test charge. As I move away from the charge, E value continuously decreases. But I want dV to be same. Difference in potential same undali kada. dV should be constant. 10 volts, 10 volts, 10 volts. But E value is decreasing as I move away from the charge. If E value decreases, dr value increases. So that is why distance between two equipotential points with equal difference, that continuously increases. Okay? It means that near to the charge, equipotential surfaces are concentrated very densely. Chara dense ga pack ayi untam. So when you move away, distance difference same untundi potentials. Kaakapothe distance continuous ga increase avutu veltundi. That is the reason. Okay, ma? So what is the note point here? You have to write dV is a constant, but as distance increases, okay, ma? E value decreases. So dr should increase. Dr should increase. That's it. Okay? Make a note. See, ma. So next we are discussing about electron volt. Listen very carefully. Electron volt is what? See. So this is a uniform electric field, and here I am placing an electron. Clear, no? Electron is a positively charged body or negatively charged body? Positively, na? Negatively. So it will experience force in which direction? Opposite direction to the direction of electric field. Okay, ma? So it will experience a force in this direction. So therefore, if I leave this electron here, because of this force, how much force? This force. Q into E, E into E. Q means the charge of electron, no, ma? And what is the electric field we are applying? E electric field. So electron will experience this much amount of force. So because of this force, it will accelerate, no? Because of the force, net force, what net force will do on a body? Net force ఏం చేస్తుంది? బాడీని యాక్సిలరేట్ చేస్తుంది. It means velocity of the body continuously increases. Velocity is increasing means kinetic energy is also increasing. Kinetic energy is increasing means body is gaining some energy. Okay, ma? So that energy gained by the electron, when it is accelerated in a potential difference of 1 volt. It means, what is the potential difference between VB and VA? It is 1 volt. Okay, ma? So if I accelerate this one in a potential difference of 1 volt, then finally electron will gain how much energy? That is called as 1 electron volt. Clear, no? Final ga daniki enta energy vastundi anedi oka electron volt. So this is the equation of work done, no? Work done is potential difference multiplied by charge. Potential difference is 1 volt, and what is the charge of electron? 1.6 into 10 power minus 19 coulombs. So therefore work done is 1.6 into 10 power minus 19 joules, which is also called as 1 electron volt. ఈ ఎనర్జీనే మనము ఒక ఎలక్ట్రాన్ వోల్ట్ అని అంటాం. క్లియర్? మేక్ ఎ నోట్.